Yes, this is some MCQs from Save My Exams. I'm going to solve them. When blue copper sulfate is heated, a white solid and water are formed. The white solid turns blue and gives out heat when water is added. So what is they telling you? That when the white solid turns blue, it is exothermic. Okay? So that means when you add water, when you heat it, when the blue thing goes to white, that's endothermic. Which term describes the blue copper sulfate and reactions? Is it the blue copper sulfate is hydrated? Yes, because you have added water. Is the reaction reversible? Yes. So C is the answer. The equilibrium shows a reaction that is reversed by changing the conditions. How can the forward reaction be reversed? So I have water here included with it. This is hydrated. But this one is reacting with water, which means if I want to reverse this, then I need to add water because water is a reactant. So if you add water, it will go to the side that has less water. And secondly, if I heat it, water will evaporate. So water will not be there. So what do I want? To go forward, I need to heat it. So to go backward, I don't need to heat it. So this one is wrong. So it's either this or this. And in the forward direction, I don't need to add water. In the backward direction, I need to add water. So you add water, but don't heat it. B is the answer. When pink cobalt sulfate crystals are heated, they form steam and blue solid. So when you heat them, that means it's an endothermic. No. Oh wait, yeah, you're heating it, so it's endothermic. When water is added to the blue solid, it turns pink and becomes hot, which means it releases heat. So it's exothermic. Which term describes the pink cobalt sulfate crystal in the reaction? So pink cobalt sulfate. So they had water, they released it, so they are hydrated. And the reaction is reversible, so D is the answer. The sign this is used in some equation to show the reaction is reversible. Two incomplete equations are given. For which of these reactions can this sign be correctly used? So again, this one is reversible. This one is not reversible in normal condition. So that's why I will just say P. The reason I'm doing that is because of this dot. The dot is always for reversible reactions. But for the rest of them, you need to look at the actual reaction itself to see if it's reversible or not. But any reaction with the dot, it's always reversible. The equation for effect of heat on hydrated sodium carbonate is shown. Statement made by 4 students are given. Okay. What's the term anhydrous? Anhydrous means that does not have water added to it. So this one is hydrated. This one is anhydrous. It is hydrated because it has water in it. Okay. Anhydrous sodium carbonate is formed. Yes, this one is anhydrous. That is correct. Steam is formed. Yes, because you can see water and a gas is steam. There's a color change from blue to white. No, because color comes from transition metals. You don't have them here. The reaction is reversible. Yes. When green iron 2 sulfate is heated, it turns white and a colorless liquid is produced. When the liquid is put back, white solid changes to green. Again, we have seen this. This is a reversible reaction, and the water is the substrate. So you see, in most of these reactions, the reversible one, the simplest example is when you add water to the crystals to make them hydrated, and you remove it for them to become anhydrous. So all of these reactions are the same way. Let me look for some other. So this is for, okay, let's look at this question. Question 11. Steam reacts with carbon in an endothermic reaction. Now, as soon as you look at it, examiner has said endothermic, that means they're talking about the right side. It's an endothermic. So that means left side should be exothermic. So make these notes in your exam. Which condition would give largest yield? Okay, now what does this mean? Every time examiner says yield, they're talking about the right side. So yield is always about the right side. So if equilibrium goes to the right, yield increases. If equilibrium goes to the left, yield decreases every time. So what do they want us to do? They're saying which will increase the yield, which means we want the reaction to favor the forward side. Now let's see. How do we make the reaction go to the forward side? Let's look at temperature. Look at each one individually. If you increase the temperature, will the equilibrium go to the right side or left side? If you increase the temperature,
Right.
yes, very good. It goes to the right side. So yield will increase if it goes to the right side. So it's either this or this. So it's one of these. Okay, now let's look at pressure. Remember, pressure depends on gaseous moles. How many gaseous moles do we have on the left side?
On the left side, we have one gaseous mole, and on the right side, we have two gaseous moles.
Yes, very good. So because of that, we will have one here, two here. So now tell me, which side produces more pressure? Right side or left side?
Right side.
Right side. Very good. So if we increase the pressure, which side equilibrium goes to?
Left side.
Left side. Very good. So that means we should decrease the pressure, so equilibrium goes to the right side. So B is the answer. Why don't you do it? Okay, let's see. First, I'll make some notes. The reaction is exothermic. That means this side is negative. So minus delta H here, so positive delta H here. Similarly, 3 gaseous moles here, 1 gaseous mole here. So I make these notes whenever I do it in the exam. Only through this, I will be able to solve it. Okay, let's see. Now, that means if I increase the temperature, equilibrium goes to the left side. So I will decrease the temperature, so it goes to the right side. So I have to decrease the temperature, one of these. Okay. If I increase the pressure, equilibrium goes to the right side. If I decrease the pressure, it goes to the left side because of more gaseous moles there. So I have to decrease the pressure. So I increase the pressure. My bad. So B is my answer. Okay. So B is the answer. Again, remember, you want a greater yield, which means you want the reaction to go forward. So then you have to think, how will you make it go forward? Forward means less gaseous moles, so increase the pressure. Forward means exothermic, decrease the temperature. Do opposite. Okay, think opposites basically.